Welcome to qnawire.
Okay, let's consider our cysteine for a second. Okay, this is our cysteine, and we're told to consider the relationship between our cysteine and S-alanine. So what does S-alanine look like? Well, it looks very similar, but the difference is that we don't have this thiol here, right? We just end at a CH3, a methyl, right? Alanine, very simple amino acid. Okay, so given that, we have some questions to answer. What is the relationship between R cysteine and S alanine, right? Um, Stereochemically, they have different stereo designations. Right? They have different stereo designations. One of them is R, the other is S, right? But they share a three-dimensional. This is kind of answering B. They share a three-dimensional configuration. Okay, and why is that? Well, it has to do with this sulfur, right? So recall that when we're determining whether a stereocenter is R or S, we have to, well, it helps to kind of put in a little hydrogen in the back if we can. Okay, and let's say okay, then we start to rank all of the substituents, right? So nitrogen obviously is going to be the highest ranked substituent coming off of this carbon because we've got carbon here, and nitrogen is a higher atomic number than carbon. So then for 2 and 3, we're comparing these two, and they are both carbons, so then we have to look at what they're attached to. This carbon is attached to a sulfur, whereas this carbon is attached to an oxygen, right? So we look at the first difference, and that's, the first difference, and then we consider the most important difference. And the most important difference compares sulfur to oxygen, and we know sulfur has a higher atomic number than oxygen. Therefore, this is priority 2, and this is priority 3. And that's how we get R. Okay? Maybe I'll make that in green. Right. But in the case on this side, right, nitrogen is number 1, and then we compare these two carbons, and this carbon's just attached to 3 hydrogens, right? This carbon is attached to an oxygen, and an oxygen, right? So this is obviously the higher priority carbon in the case of alanine, right? So all of a sudden, this is priority 2, and this is priority 3, and when we assign stereochemistry, we go counterclockwise, and that's how we get S. Okay. Okay, now, is our cysteine a D-amino acid or an L-amino acid? So we simply need to, well, we've already got the molecule organized as we needed to. We're going to look at the alpha carbon, and then we're going to go from the carboxylic acid group to the R group to the nitrogen group and determine whether that is clockwise or counterclockwise when the hydrogen of the alpha carbon is pointing back. So in this case, we're going from here to here to here. And since this is counterclockwise, this is an L-amino acid. Right? Okay. So alanine, I guess I should say R cysteine is an L-amino acid.